Good morning. So I am now here in Angkor Wat, Siem Reap. Um, the sky condition is very terrible at the moment because the AQI index is quite high. I think it's on 50 to 60 AQI. So it's very hazy, and I cannot shoot the Milky Way today. I cannot shoot anything but smog and just little star trails. So let's see what happens. I wasn't able to shoot some stars this morning. The stars we can see is actually just right above the zenith, but it's still dim. Vega this morning is actually uh, quite not that bright. So yeah, so the transparency of skies isn't clear. All right, this is Sonic Duran, and you're watching Space Adobe.
What is air quality index?
What is air quality index?
So AQI is air quality index. It is a number that ranges from 0 to 500 that indicates how polluted the air currently is and how polluted it is forecast to become. Public health risk increase as the AQI number rises. The higher the AQI, the greater the level of air pollution and the greater the health concern. So for example, an AQI number of 50 or below represents a good air quality. However, an AQI number 300 above is quite dangerous.
How does it affect astrophotography?
How does it affect astrophotography? Let us go back a little bit and identify what these pollutants are. So, let us look on this website. I normally use AccuWeather.com, and under the tab Air Quality, you would see here PM 2.5, ozone or O3, PM 10, carbon monoxide, sulfur dioxide, and nitrogen dioxide. An astrophotographer like me would typically look on the weather forecast. Definitely, we don't want a cloudy sky because, of course, if it's cloudy, you won't see anything. And we also take a look on the moon phase because each different moon phase would brighten up the evening sky. Another factor that we're looking at is the wind, of course. For an SCT user like me, I don't want a wind that is more than about 12 kilometers per hour. Otherwise, it will shake my telescope and my stars will trail, definitely trail, and I don't want that. Next is seeing. Seeing is a measure of atmospheric turbulence. It has an effect on how blurry the image is, and it is very noticeable on stars and affects guiding. And of course, it affects planetary and lunar imaging. Finally, transparency. This tells us the opacity of the atmosphere. So that's moisture, humidity, haze, and smoke. Air pollution, air quality. As I mentioned earlier, AQI measures these pollutants, right? PM 2.5, PM 10, ozone, carbon monoxide, all these that I mentioned earlier. But what we would like to focus on is this PM 2.5. PM stands for particulate matter, and 2.5 is the size of this dust particle, 2.5 microns, or 2.5 micrometer. If you would like to have an idea how small this particle is, so imagine the strand of your hair. That's 70 microns. So it means it's 30 times smaller than the strand of your hair. So these tiny particles in the air reduces visibility and causes the air to appear hazy when levels are elevated. Now let me show you some examples. So these examples are actually photos that I was able to take. These are single subs or one frame each, so they are not stacked. And I use my dedicated astronomy camera, which is ASI 294MC Pro. The telescope that I use is the one behind me. It is 8-inch Schmidt Cassegrain Schmidt. It is an 8-inch. It is an 8-inch Schmidt. It is an 8-inch Schmidt. It is an 8-inch Schmidt. And I use my telescope, which is an 8-inch Schmidt Cassegrain telescope.